Today is all about quadratic functions. Before we talk about what these are exactly, I want to do a lightning fast review of a couple of our transformation rules from a few sections ago. So I've got two functions here, f of x and g of x, and they are both transformations of the graph of x squared. So f of x is going to have this parabola shape. G of x has the same shape, but because of this -1 here, it's going to have that flipped upside down shape. It's going to have that vertical flip kind of hanging down from the origin. All right, and then both of them have a horizontal shift and a vertical shift. Let's see, f of x is going to move to the left 1 and down 3. So let's track that move. So normally that x squared graph is sitting there at the origin. We're going to move that bottom part to the left 1 and down 3. And land right there at -1, -3. So let me fill in that parabola shape. We're doing a quick sketch, so I'm not going to be too picky. All right, let's do the same thing for g of x. Remember, we're going to start with that upside down parabola hanging down from the origin. And this time, we're going to move to the right 2 and up 1. So starting at the origin, I'm going to go to the right 2 and up 1. And that downward opening parabola is going to be hanging from that point 2, 1. So let's fill in that shape. And there we've got g of x. So what I want us to focus on when we're going to start talking about quadratic functions is that landmark point that I've been moving around. And we're going to call that point the vertex. Okay, so that point right there, it's called the vertex. Either there or there, my vertex. And let's look at the coordinates of the vertex of each function. So for f of x, its vertex ended up at the point -1, -3. For g of x, its vertex ended up at the point 2, 1, right? And as you can probably guess, we can predict where this vertex is going to land by looking at that formula. Okay, so for f of x, we added 1 inside. And because that horizontal rule kind of goes a little bit backwards, adding 1 means we go to the left. So we ended up with a -1 x coordinate for our vertex. Likewise with g of x, the number kind of changed signs going from the formula to the vertex coordinate. And then the y coordinates of the vertex, because when you add, you go up, and when you subtract, you go down, they look exactly like they are in the formula. Subtract 3 means -3. Add 1 for g of x, you got a +1 in your vertex. So what does all this have to do with quadratic functions? Well, a quadratic function is any transformation of the graph of x squared. So all of these stretches, shrinks, flips, up, down, right, left, you could possibly do to the graph of x squared, throw them in a big pile, we get a family of curves called quadratic functions. Okay, so we know that A is where we're going to house all of our possible flips, a stretch, or a shrink. Those were all done by multiplying on the outside by a number. And then we just saw that the h and the k were going to tell us about the vertex. All right, so we have these two parabolas drawn here, and the two shapes are going to be determined by whether or not that leading coefficient, that a, is a positive number or a negative number. If it's a negative number, it's going to cause that flip to happen. So we're going to say that this shape over here happens when a is positive, and on the right, we get that shape if that number a sitting out in the front is a negative number, if it caused that flip, right? And h and k tell us about the vertex. And the vertex is that point down at the bottom or at the top. And we write that the vertex is h, k. All right, because in the formula, that's why we write it as x minus h, because we saw that that number was going to sort of change its sign as it moved into the coordinates of the vertex. All right. There's one more attribute of this graph that I want to show you, and that is this vertical line I'm going to draw that goes right through the vertex. And we call that line the axis of symmetry. All right, and it's pretty easy to see why you would call it that. If I were to fold my paper along those green dotted lines, that would be the line that would make the graph land right on top of itself. It's where it's symmetric about. And it's a vertical line, so it needs the equation of a vertical line. X equals a number, and the number is just going to be the x coordinate of the vertex. So x equals h. All right, so let's see if we can put this all together and come up with the equation of a parabola. So I've graphed a parabola for us here, and we're going to try to find the formula for this quadratic function. So I'm going to remind us of our function, f of x equals ax minus h squared plus k. All right, so we need to figure out the values of a, h, and k to be able to have this formula for this function. So the first thing that I'm going to do is figure out the vertex. This is the easiest parts of the formula to do. So my vertex is sitting up here at -2, 3. And those tell me what my values of h and k are. So when I go write down my formula, I still don't know what a is. And I'm going to change the sign from the x coordinate to the vertex. It's going to end up being +2. So we kind of did a minus a -2 and got a +2. And then k is going to be exactly the number that's in the vertex. All right, the last thing I have to do is figure out a. Now I've got a pretty good idea that a needs to be a negative number, right? Because we've got that downward opening parabola, but does it need to be -1 or -5 or -0.5? So we need to figure out what that number is. The easiest way to do this is to pick an easy x coordinate to plug in. The easiest one is always x equals 0. So if I plug in x equals 0, then I better get that f of 0 is equal to a y coordinate of 1. Okay, that's what the graph has. So I'm going to plug in f of 0 into my formula thus far. So that's 0 plus 2 squared plus 3. And then I know that that has to be equal to 1. If it doesn't equal 1, then I've got the wrong formula for this particular parabola. Right, so let's simplify this a little bit. I'm going to do 0 plus 2 is 2, squared is 4, plus 3 equals 1. Subtract 3 from both sides. That leaves me with a times 4, or 4a. And 1 minus 3 is -2. Then I'm going to divide both sides by 4. And then a, let's see, I can reduce that fraction, right? I can divide by 2 on top and bottom, and I get -1 over 2. So that's the coefficient that I need on the front of my function. And it is negative just like I suspected. So let's plug that in to the function. So last I had was up there. I'm going to make this, instead of a, I'm going to write -1/2 x plus 2 squared plus 3. All right, so the vertex is the easiest part to figure out about the formula. Calculating what that a has to be takes a little bit of arithmetic. We got one more video to go on quadratic functions. See you there.